Okay. So, am I on the board yet? Not yet. Okay, so I told you with number 3b, there are different ways to start. So personally, I think it would have been the most difficult if you squared first. Okay. Remember we said that BODMAS is there for a reason. If it's at all possible for you to do what's inside of the bracket first, then that is just safer and easier. So I would try to do something inside of the bracket first, like for example changing tan to sin over cos. Because if I did that, I already have the same denominators. And then I can just add the numerators. Okay? It would look like that. Change to sin over cos. And then just do the subtraction there. Okay? So I wrote it like that. Do you understand what I did there? Okay, now I just want to show you here what I wrote here with the highlighter. That's raising a powers rule. It says when you've got a fraction that's raised to a power, you can square the top and you can square the bottom. Or it's actually saying we multiply that exponent with the one on the outside and we multiply that exponent with the one on the outside. But just remember, in this case, it didn't make such a big of a difference. But when you multiply that square in, here at the top, it mustn't go to the 1 and to the sin. It must go to 1 minus sin in brackets. Does that make sense to you? So actually it does make a big difference, because if you just took it in, you multiplied it with sin, and you multiplied it with 1's exponent, you'd have 1 minus sin squared. Do you agree with me? And 1 minus sin squared's brackets will be 1 plus sin, 1 minus sin. Okay. That would be wrong. If you did it correctly, and you put the brackets and then the square, like that, it would mean you'd have 1 minus sin, 1 minus sin. Do you understand the difference? So you can't multiply that one in like that. It multiplies to the numerator and it multiplies to the denominator, but to the whole numerator and the whole denominator. If there are two terms, it's in brackets square. Do you understand, grade 11s? It's very important. And you can see if you did that wrong, it makes an enormous difference. Because if it was 1 minus sin squared, except for the brackets being different, it's also cos squared, which it's not. Okay. So I have this at this stage. I just wrote that one there. Please don't write it. I wrote it to show that now I'm looking at the answer to see what I want. Okay. At the bottom I want 1 plus sin theta. So when I have cos squared theta, I know I'd rather change it to 1 minus sin squared theta. That gives me the hint that I want to do that. Okay? So I change it to 1 minus sin squared theta. That one I leave as it is because I want the numerator to be 1 minus sin theta. And then I factorize the difference of two squares and I cancel the 1 minus sin with one of the 1 minus sin brackets at the top. And then my answer is the same as the right hand side. Okay. Now I just want to quickly show you what happened at C. The reason I didn't want you to do it because it's never happened. They told you at C that you must refer to number 1A in your textbook. So I just want to show you 1a. 1a said that 1 plus 2 sin theta cos theta is sin plus cos squared. Do you remember that sum? But we started from the left side. We changed the left side to look like that one. Okay? So they wanted you to see that 1 plus 2 sin theta cos theta is what's there at the top. And then you can substitute it with that bracket. So that's never going to happen. But then the rest, it just cancels out. And then you get the right answer. So I'm not going to let us waste time on that. Okay. This is not a new trigonometric sum. I just want you to write example 1. So what this is everything has been thrown together. So while you're writing it down, I'm quickly going to recap. So what we learned in trigonometry this term so far is that we have our reference angles, né? That 180 plus or minus, 360 plus or minus. Then we got our co-angles, which was 90 plus or minus and 270 plus and minus. And then we also learned about negative angles, going in the other direction. The sin of a negative is a negative sin. The cos of a negative is the positive cos of the angle. The tan of a negative is the negative tan of the angle. Do you remember that? Okay. Then after that, we also learned about special angles. Angles like 30 degrees, 45 degrees, 60 degrees, 0 degrees, 90 degrees, those ones. Do you remember them? And then we said, if you see them, if you were living, or if you were in grade 11, 20 years ago, you would have drawn the special triangles. But now you just have to recognize it and you can substitute it into your calculator. Ne? Okay. And then the last thing we learned was the identities that we just did. So now they put everything together. So we have here tan 225 plus cos 180 minus theta times sin 90 plus theta divided by sin negative theta. Is that 225 okay as it is? No, what am I going to do with it? 180 plus 45. Are you all happy with that? Okay, so that's how we're going to change that one. This one, 180 minus, we're going to say it's in the second quadrant. It's cos, so it's negative. 90 plus, it's in the second quadrant. What is sin in the second? Positive, but it's also going to change to cos. So it's positive cos theta. Here at the bottom, the sin of a negative, negative sin of theta. Okay, that's what we're going to do. So, I wrote tan as 180 plus 45. That plus cos 180 minus theta became minus cos theta. And then sin 90 plus became cos theta. And at the bottom, sin negative theta became negative sin theta. Now in the next step, I said that 180 plus is in the third quadrant. What is tan in the third? Positive. So it's positive tan 45. Cos times cos is cos squared. So it's tan 45 minus cos squared over negative sin theta. Do you all agree that 45 is a special angle? Yes. Do you know what tan 45 is? It's one that I told you you must remember this one. It's a special one. It's 1. No? So I can substitute tan 45 at this stage. And it becomes 1 minus cos squared divided by negative sin. Now before we did identities, this is where we would stop. We wouldn't be able to go any further. But now we've done identities. Do you see something? What do you see? What is 1 minus cos squared? And then the bottom sin can cancel out with one of the sins at the top because it's a square. And then my answer will be negative sin theta. Okay, you done? Example 2. Just give me a second, I just want to erase here. Okay, do you all see that those are not specialish angles? Do you see it? No? We start to recognize when it's going to be a special angle. But even in the simplest form, they're not special. It's a 40 and it's a 50. Go. So I also want you to take note that there are two acute angles, two different ones. Do you see that? There's a 40 degrees and there's a 50 degrees. That's a problem because those two angles, or the identity rules and all the rules that we know, won't work when the angles are different. The only time it works is if you've got a diagram. Do you remember the diagrams that we drew? And then you knew that angle is 20, then you had the other one is 70, and then you had the side lengths, and then you could do it. Remember that? Okay. So then it would be fine. But in a sum like this, we can't have the angles really to be different. We would like to change them to be the same if it's at all possible. Now, if I look at 140 degrees, what would I change it to? 180 minus 40. Tan 40. I can't change that one. So that already actually tells me I'm going to have to make it 40. No? 220. 270 minus 50. 180 plus 40. We need to get them the same. And I can't change tan. So it's going to have to be 40. How am I going to get that 50 to be 40? 90 minus 40. So you see there you choose to use the co-angle. But you don't use it unless you have to use it. Okay. So I'm going to change them. 140 becomes 180 minus 40. That one stays as it is. 220 becomes 180 plus 40. 50 becomes 90 minus 40. Okay, 180 minus which quadrant? 180 plus 90 minus first. Okay, what is cos in the second? Negative, but the square changes the sign from the quadrant. Nee? So it becomes positive cos squared 40. That tan stays as it is. Cos in the third is? So I put in my times. Nee? Times negative cos 40. Sin in the first? Positive, but it changes to cos 40. So do you understand where all the positives and negatives are and went to and came from? That one was negative, but the square made it positive. That is a minus. It was there. That is in third quadrant, so it's a negative cos, and that one is first quadrant, so it's positive. Now, do you see? I know you guys sometimes struggle to see this. This is my first term. Okay? This whole thing is my second term. Do you understand it like that? So these ones I multiply, I say negative times a negative, it becomes a positive tan squared times cos squared 40, because those two cos multiply with each other. Now, who has a plan for me? What can I do now? Komoto? We can take out a common cos. Yes, that's one option what I can do. Is there any other option? Remember, we're always looking for three: trigonometric, algebraic, and fraction. There's no fraction, eh? What Komoto said was the algebraic. Is there trigonometric? What? Tan. The easy one. Do you see tan? I can change tan into sin over cos. Okay, now you always have to keep all of it in mind. Even if you found something to do, if you found to take out something in common, see if you haven't missed one, because remember I said that the different ways can result in an easier sum. Now let's make a plan. Let's just look into the future a bit. If I take out the cos in common, what I'd have inside my bracket is 1 plus tan squared 40. Okay, that would be the next thing. If I change tan into sin over cos, I'd have a cos and a cos that can cancel. Which one would be easier? Sin over cos. Do you all agree with that? So it wouldn't have been wrong to take out something in common. But it would have been a much longer road to get to the answer. So think about it. There's always, well, not always, most of the time, there are two options. Don't just pick the first one you see. So I changed that one to sin over cos. And now my cos can cancel out. And I'm left with cos squared plus sin squared. Can you tell me anything about cos squared plus sin squared? Can you believe that? Okay, this activity is exercise 9 on page 159. So I asked the Afrikaans class to do A, C, D, and F for tomorrow, or for today. But I'm not going to give it to you to do for tomorrow. This is not normally a sum that we would find in an exam question, but they can ask it. So on your own time, you can go through them, okay? As we have time, maybe I see you at some stage, then we can do it. You will remind me. But it's not an exam question. It's normally, the last question will be the identity, okay? The rest might be the equations that we're going to do next term, okay? So let's rather start with the analytical geometry. Do you know what analytical geometry is? Do you? Okay, so analytical geometry is all about straight lines and the quadrilaterals. Do you remember the quadrilaterals? You did it in geometry in grade 10. So it's the square and the rectangle and the rhombus. This is not the one-on-one. The rhombus and the parallelogram and the kite. Okay, so these ones we get a lot in analytical geometry. Okay, let me just check if I have the right one here. Alright, you can write the heading, Analytical Geometry, grade 11. I will tell you what to write. So the first thing is the distance formula. Do you remember the distance formula? It's d equal to the root of x2 minus x1 squared plus y2 minus y1 squared in a square root. Do you know where that formula comes from? Can I tell you? It's Pythagoras. It's Pythagoras on a Cartesian plane. Do you see, if you were to do Pythagoras and you take over, let's say you wanted to get the hypotenuse's length, ne? The hypotenuse's length. Then you'd have r squared plus r squared, you take the square root over. So it would be h equal to square root of r squared plus r squared. Does that look like what's in there? R squared plus R squared with a square root. Now the only reason that isn't R is because it's on a Cartesian plane. So if you've got a line on the Cartesian plane, it starts at 2 and it ends at 5. What's the length of that line? How did you get to 3? You said 5 minus 2. That's why it's x2 minus x1. So you subtracted 2 x values to get your r. You subtracted 2 y values to get your other r. You square both of them, you add them and take the square root. The reason I'm telling you this is because I remember when I was at school, I was confused when I wrote the test because I didn't learn my formulas like you guys don't do, ne? Then you don't know, is that a minus or is that a plus? And when you write it wrong, you get everything wrong. So that plus is there because it's Pythagoras. That minus and that minus is there because you're trying to get the length of the line. And it's between two coordinates. We remember that? Okay. So we say we use this formula to find the length of a line segment or to find the distance between two given points. Example, I want you to write down distance formula and write down the formula. Are you done? Okay, look here. This is what they would ask. They want to find the distance of the line AB. Okay. So what they're doing is we're finding the x value, the length of x, and we're finding the length of y. We square them, we add them, and we take the square root. Then we've got the length of the hypotenuse. Okay. So what would we do to find the length of that x? We would say that's 6, né? From there to there is 6, and from there to there is 1. So we would say 6 minus -1, so that it can become plus. Né? And if we want to find the length of that side, we would say 6 minus 3. Do you agree with that? That would give me 7. That would give me 3. If we were to do Pythagoras, we would say, I take these two, I square them, and I take the square root. That would be 49 plus 9. The answer would be square root 58. And that would be the length of line AB. Okay. But instead of going and drawing it every time we need to calculate it, we've got the distance formula that says, doesn't matter which x you start with, né? A or B. You take one of the x's minus the other x. But you see here they started with B's x. Can you see it? Then you must start with B's y. Do you hear me? Okay. So they say x of B minus x of A. Y of B minus y of A. And that whole thing, after you've substituted, you type it on your calculator as it is there. And you get the final answer. Do you understand? Okay, then what can also happen is they can give you 2 points, but you don't have the full coordinates. And they tell you that the line is 5 units long. Find the value of A. So remember, that's what we do in maths. First we walk forward, then we walk backwards. So the only difference is now you've got the answer. You still substitute, and then you get everything to one side. So look at what they did. After the substitution, they took, first they simplified what's inside of the bracket. So they squared that bracket. Do you remember how to square a bracket? First one times itself, first one times second one times 2, the second one times itself. That one was 4 squared, they wrote to 16 there. So you've got a trinomial inside there, do you see? I take the square root over. So I square both sides. It's actually what I'm doing. Then I have 25 on the left-hand side, and this side the square root is over. Oh, it's gone. Then I need to get everything on one side, get them equal to 0, and then I can factorize it. Do you remember when we started this year, I told you everything in grade 11 is about quadratics, quadratic trinomials. So this is what it gets to. Now we get 2 answers. Now the reason that you get 2 answers, I quickly want to show you on the board as well. The reason why we get 2 answers is if A is here, and I only know the x value. Let's say this x value is, the y value. This y value is 3. Then it's going to be 3 everywhere. Do you agree with me? But there's going to be a place where B is. That's 5 units to the right of A. And there can also be a line piece that's 5 units to the left of A. Do you understand that? This can also be 5 units. So obviously you must get 2 answers. Because x can either be, for example, -3 or 2, whatever. That's why you get always, when you have the distance, you will get 2 values. Now they said here, find the values of A. Do you see they say value in brackets? Because there are two possible answers. Now, if they give the question like that, you give both answers. And do you understand why you have two answers? Okay. But if they were to say, give the answer in the first quadrant, or you have a diagram and you can see B is in the first quadrant, then you're going to have to choose the positive X answer. Do you understand? Okay. Or if they say in the second quadrant, you know it's going to be the negative or whatever. So here we've got two answers. A is equal to 8 or A is equal to 2. Easy. Do you understand it? Okay. They can also ask if coordinates of triangle ABC, and then they give the coordinates, show that ABC is a right angle triangle. Now, before you look at the solution, look at the question. Show that triangle ABC is a right angle triangle. Is ABC a right angle triangle? Are they asking, is it or isn't, or is it? That was a very confusing question, but I see you understand what I'm asking there. It is a right angle triangle. You have to show that it is a right angle triangle. What would make it a right angle triangle? You're thinking about an isosceles triangle. What would make it a right angle triangle is if Pythagoras works. So we need the length of the sides, and then we need to square the two shorter sides. Add them, and see if it's the same answer as the hypotenuse length squared. Does that make sense? If the question was, show that it's an isosceles triangle, you would find the lengths, you would see two of them are equal in length, you'd say thus it's an isosceles triangle. If they said show that it's an equilateral triangle, you'd find the three lengths, all three are the same length, see it is an equilateral triangle. But if your Pythagoras doesn't work out here, then you must know you made a mistake, because they're not asking, is it determined whether this is a right angle triangle? They are saying, show that it is. Show me that this shirt is blue. It is blue. Do you understand? Okay. So when we look at the solution, do you see everything is in third form? Don't be scared, it's going to be in third form. Okay, we don't use decimals, we use third form in analytical. So you get your three answers, square root 72, square root 18, square root 90. Which one is the longest? Square root 90. So I'm going to square the square root of 90, because that will be the hypotenuse. The hypotenuse is always the longest side. The square root of, or the square of the square root of 90 is 90. Okay? Okay? Then we need to square these two, which means the square roots disappear, and add them. What's 72 plus 18? 90. So do you see? The longest side square is the same as the sum of the two shorter sides squared. Therefore, it's a right angle triangle. Do you understand that? Okay. Write down the next one. The midpoint formula. Okay, I want you to make a star next to this formula. This one is very important. I want you to take note. Must I zoom? Are you struggling to see? x plus x divided by 2 and y plus y divided by 2. Do you know how many equations you need to solve or to find the value of one unknown? Then you need one equation. The equation is the one with the equal to sign, eh? Do you know how many equations you need if you want to solve two unknowns? Then you need two equations. If you want to solve three unknowns, you're going to need three equations. Do you remember simultaneous equations that we did in the first term? We had to solve x and y, ne? How many equations did we have? Two. Okay? So for two unknowns, I need two equations. When I look at the distance formula, the one that we just wrote down, how many equations is that one? One. It's one equation. You can only calculate one variable. Yes, x can have two answers, but you can only calculate x. You cannot calculate the x and the y. You cannot calculate x and the distance. Only one, because it's one formula. If you look at this midpoint formula, I need you to see that this is two formulas, two separate formulas. There's a formula to find the middle of the two x's, and there's a formula to find the middle of the two y's. They just write it as one because the midpoint is a point. Do you know what a point is? It's a coordinate. It's x, y. That's why it's written in one thing. But it's two separate equations. So next to where you wrote this, I want you to also write down x1 plus x2 divided by 2 is the x midpoint. This is equation 1. y1 plus y2 divided by 2 is equal to the y midpoint. This is equation 2. Now the reason I am telling you this is it's going the question is going to come where you're going to have to calculate two variables. Then the only equation or the only formula you can use is midpoint. You cannot calculate two unknowns with distance. You cannot calculate two unknowns with the gradient. You can only calculate two unknowns with midpoint. So write it there. With this one, I can calculate two unknowns or two variables. Okay. Now I'm just going to zoom out a bit. We use this formula to find the coordinates, which is two values, of the midpoint of a line segment. For example, find the coordinates of P, the midpoint of AB, if A and B are those coordinates. So you just you can write it down like that. We substitute the two x's, we substitute the two y's, divide each one with 2. Do you see they are not overflowing or going into each other? It's the x calculation, it's the y calculation, and then you get your two separate answers. Okay, that y values did not influence my x values, and the x values did not influence my y values. Easy, ne? Very difficult if you don't know the formulas. Example 2. Given the midpoint and the point, determine the unknown point. Now you've got they tell you the midpoint is 2 and negative 2. They tell you A is 3 and 1. And you have to calculate B, which is A and B. Do you see 2 unknown variables? The reason it's fine is because it's 2 equations. So you see where they write the solution, it's even difficult to write it like this. You could have immediately started by saying 3 plus A, it's that 3 plus A divided by 2 is equal to 2. And then 1 plus B divided by 2 is equal to negative 2. That's where I get that. And then I just simplify and solve for B and A. And then I get A is 1, B is negative 5. Easy. Okay. We'll just skip those examples for now. The gradient formula, you know the gradient formula. Because the gradient formula we use in algebra, when we look at the functions, the straight line, you remember that one? No? Yes? Yes? And we also use it in analytical geometry. So in algebra, we usually write A is equal to y2 minus y1 divided by x2 minus x1. Doesn't really make a difference, ne? But in analytical, we use M as the symbol or the variable for gradient. Okay, this is also just a substitution into the formula. They will tell you, for example here, find the equation of the line AB, which is parallel to that. Okay, I don't want to do that one right now. Is there not another example first? Let me just check. Okay, let me just quickly tell you. So what can happen is they can give you 2 coordinates. Let's take this previous examples of the midpoint. Do you see that A and B? Here they ask for the midpoint. They can also ask you for the gradient of this line. So then you would take y minus y divided by x minus x and simplify. That's not difficult, eh? Okay. Now let's look at what they've given us here. They say that you must remember, and this is so important in grade 11, if lines are parallel, then the gradients are equal. Okay? If lines are parallel, then the gradients are equal. Doesn't it make sense if this pen slope is 5 and this pen slope is also 5, doesn't matter where it is or this pencil, then they will almost be parallel to each other. It makes sense. If this one is not 5, they're going to cut each other somewhere. They will always intersect. Remember, parallel means they will never intersect. So when the gradients are the same, they are parallel. So we say if M is equal to M, then it's parallel. And then the second one that's very important is perpendicular. Perpendicular, when it makes a 90-degree angle. Perpendicular. There are 2 ways of remembering or saying this. The first way is that when you multiply the gradients, the product of the gradients is equal to -1. The product of the gradients is equal to -1. If they're perpendicular, the product of the gradients is equals to -1. Now, I just want to tell you a very easy and quick way to recognize it is if you've got one gradient and the other one is perpendicular to it, then it will be the reciprocal. Do you remember what a reciprocal is? Swapped around with a negative. Okay, are you all done writing? I just want to go to the right screen. So, if I have, this is now for perpendicular lines. If the one gradient is a half, the other gradient will be, swap it around, give it a negative. Then you know they are perpendicular, those two lines. Let me show you another one. If the one gradient is equal to negative 2/3, let me finish. The other gradient will be 3/2. Okay. Does that make sense to you? Do you remember these things? Did you do it in grade 10? Okay. I want to ask you to do for me for tomorrow. Let me just see what I want you to do. On page 65, I just want you to do question 1 and question 2. It's 4 sums. Okay. The first one is about the distance, and the second one is about the midpoint. Just those 4 sums for tomorrow. Please, page 65, exercise 1, number 1 and 2.